Yes, very good evening students. Welcome to Akshara Online classes. This is Gafar sir, your physics faculty. Let's start our session. Today it is our first class. In that first class I will explain about vectors. Okay, the topic is for you, the first class is vectors. So our topic name is what? Vectors. Vectors. So here what is mean by vector, where we are using this vector, the everything we'll discuss today. So here, so when you are talking about vector, first you must know about physical quantities. So let us talk about first physical quantities. Physical quantities. Physical quantities. What is mean by the physical quantities? Physical quantity means anything which can be measurable. Any quantity which can be measurable are known as physical quantities. Understand? So, for example, mass, time, length, force, momentum, energy, these all are considered as physical quantities. Understand? So, the quantities known as physical quantities which can be measurable. And here these physical quantities we have divided as three ways. So these physical quantities we will divide as three ways. That is nothing but scalars, and next one is vectors, and the third one is tensors. Vectors, scalars and tensors. This is the division of physical quantities. See here how I am dividing the physical quantities here. Physical quantities I have divided as three types. First one is scalars, second one is vectors, and third one is tensor. Which means that scalar nothing but a physical quantity, and vector also nothing but a physical quantity, and tensor also physical quantity. But what is the difference among these three quantities, these three types? See now, let us talk about a scalar. When you are talking about the scalar, so here scalar means any quantity has only magnitude. Only magnitude. Any quantity has only magnitude is known as what? Is known as scalar. And similar way, any quantity has a magnitude and direction. Direction, both magnitude and direction, both having that physical quantity is known as what? Vector. And coming to the tensor, tensor means any quantity has magnitude, direction, and it must has many dimensions. It must has many dimensions. Many dimensions are known as what kind of quantities? Tensor quantities. Got my point? So once again I am repeating: scalars, vectors and tensors. Here scalar means any quantity having only what? Magnitude. The quantities are known as what kind of quantities here? Scalars. Similar way, the quantities has magnitude as well as direction are known as what? Vectors. So similar way, the quantities having magnitude, direction, and it requires many dimensions to explain those physical quantities are known as what? Tensors. Let me give some examples here. The examples for scalar, vectors and tensors. So let us give scalar examples. Scalar examples. Let me give scalar examples. Here scalar has only magnitude. When you are talking about magnitude here, scalar, the scalar quantities are nothing but, simple example is what? Mass. Mama, mass. The mama mass is a what kind of quantity? This is a scalar quantity, because the mass not required any what direction to explain. Since it is a mass is a what kind of quantity? Scalar quantity, because in which direction you can bring that mass, it is same quantity you have. Even though direction, if you change, for example, it is a 1 kg mass is moving towards east direction, or 1 kg mass moving towards north direction, the quantity of mass cannot be changed. Got my point? Since the mass is a what kind of quantity? Scalar quantity. Similar way, time. Let me take time. When you talk about time, the time is a scalar quantity, because anywhere, if you go x direction, if you go y direction, if you go z direction, if you go east and north and south, anywhere, for example, 1 hour if I take 1 hour in the east direction, in the west direction, in the north, south, x, y, z, any direction, the 1 hour quantity is 1 hour only. It can't change. 1 second is 1 second only. It can't change by the direction. So that the time is also what kind of quantity here? The scalar quantity. Even you can take energy. Energy also what kind of quantity? Energy also what kind of quantity? It is a scalar. Generally, energy will measure in joules. This mass measure in kg. This time will measure in seconds. Got my point? So that way the energy units are joule. SI unit is joule. For example, I am having 10 joules. Example I am taking, I am having 10 joules of energy. If you go any direction, the 10 joules energy is 10 joules only. That with respect to direction, the energy value, the magnitude of energy value can't change. So the energy also what kind of quantity? Scalar quantity. So these are the best examples for what? So scalar quantities. Let me talk about another quantities. The other quantities are, so this is examples for what? Scalar. Another quantity is what? Vector. Vector. Here vectors examples. So if I talk about vector examples, so vector has magnitude and direction. When the vector has magnitude and direction, which means that with respect to direction, the magnitude will change of the physical quantity. With respect to direction, magnitude will change. So, for example, best example for what? Best example for vector is, let me take force. Force is a vector quantity. Look at here. This is an object. This is an object. When this object, on this object, one F1 force is acting in this direction, and another force F2 is acting in this direction. So two forces are acting in the same direction. One is F1, one is F2. The two forces are acting in the same direction on the same body, on a body. When the two forces are acting in the same direction, what will be the resultant force? What will be the total force here? Total force, simply it becomes F1 plus F2. The effect is become F1 plus F2. Similar way, let me take, I'll take one more slide. This space is not sufficient. So once again I am taking the object here. This is the object. On this object, two forces are acting. This is F1 force, and one more force is this is F2 force. Two forces are acting in the same direction. When the two forces are acting in the same direction, the total force total force in this situation is how much it here? The total force in this situation F1 plus F2, isn't it? F1 plus F2. In the next situation, the same on the same body, this direction F1 is acting and this direction F2 is acting on the same body. In this situation, the total force in this situation is F1 minus F2. In before case, when two forces are acting in the same direction, the total force is F1 plus F2. If the two forces are acting opposite direction, same quantities, but when they are acting opposite direction, the total force is F1 minus F2. Similar way, one more situation will take. If two forces are acting, one force is acting this direction, another force is acting this direction. So two forces are acting here, how much angle? With 90 degrees. Then what is your resultant force here? Resultant force cannot be equal to F1 plus F2. It can't be equal to F1 minus F2. And one more, if you take here one more situation. So this is a object. On this object, one force is acting this direction, that is F1. Another force is acting this direction, that is F2. In this situation, the net forces can't be equal to F1 plus F2. It can't be equal to F1 minus F2. Even it can't be equal to this situation also. So the thing is, with respect to the angles, here the angle is between the two forces is 0. Here angle between the two forces is 180 degrees. Here angle between the two forces is 90 degrees. Here angle between the two forces something like 120 degrees. Means depending on the angle, the force magnitude, resultant force or total force is changing. So these kind of physical quantities with respect to angle, with respect to direction, the values changes, the kind of physical quantities are known as vector quantities. So here the best example for vector quantities is what? Force. Okay, vector quantities best examples are what? Force. Vectors best examples are what? So force is a best example. Force is a best example. Another example for vectors is momentum. What is that? Momentum. Another one is acceleration. Another one is displacement. These are the best examples for what? Vectors. Understand? I hope you got clarity why we are taking as a vectors some physical quantities we are taking as a vectors, because with respect to angle, with respect to direction, the quantities magnitude, the quantities behavior will change. That kind of physical quantities are known as vectors. Best examples are what? Force, momentum, acceleration, displacement, torque. So many we have in our physics world. And coming to the another physical quantities, those are nothing but tensors. So let me talk about tensors here. So tensors also having magnitude, direction, as well as it requires many dimensions to explain. So those kind of physical quantities are known as tensors. Here the best examples for tensors is, first one is moment of inertia. Moment of inertia is the best example, represented with letter I. Next one is we can take temperature. Temperature is also what kind of quantity? Tensor. But generally this temperature we will consider as a scalar, but it is not a scalar. What it is? It is a tensor quantity. Moment of inertia, temperature, susceptibility. Third one is what? Susceptibility. Susceptibility is also what kind of quantity? It is also scale tensor quantity. So this is about what? Vectors, scalars and tensors. So once again I will revise what it is. Look at here once. So we are having physical quantities. Just revise here. Physical quantities. How many types of physical quantities we have? Based on something we have scalars, vectors and tensors. Scalars means the quantities only has magnitude, it not requires any direction. To explain, though quantities are not known as scalar quantities, and who the quantities having magnitude as well as direction, those quantities are known as what? Vector quantities. Tensor means magnitude, direction as well as it requires many dimensions. It has many dimensions are known as what? Here tensors. So examples for scalars are mass, time, energy, next distance, speed, all are considered as scalars. Coming to the vectors, the vector best example is force, momentum, angular momentum, linear momentum, next displacement, acceleration, torque. So these all we consider as what kind of quantities? Vector quantities. Coming to the tensors examples are moment of inertia, temperature as well as magnetic susceptibility, simply susceptibility. So these are the quantities about vectors, scalars and tensors. Now our interest here only about vectors. Up to your standard we don't have any tensors. This tensor you will learn in after intermediate, like in degree level you will learn this tensors. You will not even learn in +1 +2 level, means intermediate level, even you can't learn this tensors. After intermediate, in the level of degree you will learn in this tensors. Coming to the only this discussion only now about must learn about vectors. So our topic is what? Here vectors. Now how do you express the vector? How many types of the vectors and how do you calculate the vectors? These are the things we will learn today. Understand? First, representation of the vector. The first thing is what? Representation of the vector. Representation of vector. Generally vector we will represent in geometrically. Geometrically we represent as, for example, this is a vector. This is a vector. For this vector here, this is called tail of the vector, and this is called tail of the vector, and this is called head of the vector. So the length in this case, the arrow represents the direction for the vector, and this length from here to here, the length represents the magnitude of that vector. So then let us give the names here. The names are, the first is A and this is B. Here how can you write mathematically this vector? As vector we will represent as AB. This AB represents the magnitude, but it has a direction. This arrow head represents the direction. So totally this is where we can represent the vector mathematically. This is the way we can represent the vector geometrically or diagrammatically. So I hope you have understood. In another way also, look at here, in another way, the other way of representation of the vector is, you know, this AB magnitude, let me take A, the AB magnitude, let me take A, magnitude means this length you can consider as A. Then how do you represent, when you have the magnitude, even you have to show the direction. So you can show the direction as A bar. So simply AB bar represents A bar. Here AB combinedly represent the magnitude, this arrow represent the direction. So here also this A, small a, sorry, this small a represents the magnitude and this arrowhead represents the direction. This is the way we can write the vector here. So now let's talk about let's talk about different types of vectors. So I hope you have understood representation of the vector. So this is the representation of the vector diagrammatically. So this is totally representation of the vector mathematically. So in this diagrammatic representation, this length is representing the magnitude, this arrow represents the direction, and this point, the starting point is called a tail, and the head, this arrow is representing the head in a diagrammatically. The same thing mathematically, this AB represents the magnitude, and this arrow represents the direction. Similar way, in another way expression is what? This A is representing the magnitude and this arrow represents the direction. But here sometimes even we can represent the vector magnitude as in terms of mod. Mod means, look at here, in this case AB bar represents the vector and AB bar magnitude represents the magnitude. Or for example, if I take this, A bar represents the vector and mod A bar represents the magnitude. So this is also, we express the magnitude as well as vector. So I hope you have understood what is this magnitude, what is this vector. This is the way we will express the vector. Now coming to the types of vector. So better note down types of vector. Types of vectors. So children, the types of vector, when we talk about types of vector, here many types we have, but in that some important types I will discuss. Okay, many types we have, but some important in our daily life we are using some important vectors, though I will explain. First one is like vectors. First one is what? Like vectors. This is the first first type of vector. First one, what is like vectors? Like vector means the vectors having different magnitude acting in the same direction. Having what? Different magnitude. Different magnitude and acting in same direction. Different magnitude and acting in the same direction. So I'll show in a diagrammatic way. So the first one is, let us take vector. This is a vector A bar. This is a vector A bar acting in this direction. And another vector, let me take another vector here. This is a other vector B. So here, look at here, this vector A and this vector B all are acting in the same direction. Okay, direction is same. But what is the magnitude here? The magnitude, length, generally length represents the magnitude. When it is length represents the magnitude, for this vector A, this is the length. For this vector B, this is the length. Both are having different length. Since these two vectors we can consider as like vectors. Got my point? Like vectors. So I hope you understood what is like vector. Now coming to the other type of vector. The other type of vector is unlike vectors. Unlike vectors. The other type of the vector is unlike vectors. Then what is mean by this unlike vectors? The vectors has a different magnitude and acting different direction. Acting different magnitude with different direction. So I'll show with diagrammatically. So look at here, this is one vector and this is other vector. I hope it is not appearing. It is not appearing. This is other way, and one more I'll take here. One more. This is another vector, and this is other vectors. One more I'll take. This is another vector. So this is a way. This is A. This is B. This is A. This is A bar. This is B bar. This is C bar. This is D bar. This is some E bar. So this is the way many vectors we have. But these many vectors having different magnitude and they are acting in different directions. Those vectors known as what kind of vectors? Unlike vectors. Next, very important one here, unit vector. Very important one is unit vector. What is this unit vector? Very, very important. This unit vector is very, very important. I am emphasizing you, this vector is very important. Now what is mean by unit vector here? Unit vector means any vector having magnitude is unity. Any vector, it is any vector. Any vector having magnitude is what? Magnitude is unity. Unity means 1. Any vector having magnitude unity is known as what kind of vectors? Unit vector. But what is this use of this unit vector? So unit vector, we have a use with unit vector. The unit vector use is it will represent the direction. Represent the direction. What is the use of this unit vector? And this is the purpose we will discussing here, the unit vector. So what is the unit vector will do? It will represent the direction of any physical quantity. Generally, this representation of the unit vector as, for example, A bar is a vector, for example. If A bar is a vector, how we can represent the unit vector of this A bar? We represent unit vector, A bar is a vector. For this vector, we have to show unit vector as A cap. Understand? A cap. So here A cap with A cap become A cap is equal to A bar by magnitude of A bar. So this is the way we will represent the vector form. A cap. So this is A cap. So this is A cap. Here A cap means unit vector. Whose unit vector it is? Vector A unit vector. But how can you represent this vector A unit vector? Vector A unit vector as A bar upon magnitude of A. But from this, observe one thing, from this equation, A bar we can write as, from this we can write A bar is equal to magnitude of A bar into A cap. So what is the generalized equation here? Look at here. A bar is a vector. So you can write here vector, that is equal to, what is this magnitude of A? I mean, what is this mod A? Mod A represents the magnitude. And here A cap represents the unit vector. But unit vector, what it will represent here? Unit vector represent the direction. Since any vector has magnitude and unit vector, multiplying with the unit vector, it shows as what? It shows as a vector quantity. So now, how do you use this unit vector to represent the vector? Let's see. Now I will give some examples here. So better, please note down what I am explaining here. Please note down. So let's talk about these vectors. How do you represent the vector with unit vectors? Let's see now. So unit vectors in x direction, unit vector in general in x direction is I cap. Unit vector in x direction is what? I cap. In y direction is j cap. Unit vector in x direction is I cap, y direction is j cap. Same way in z direction is k cap. So which means any physical quantity acting in x direction, how can you represent? Magnitude, and if you multiply with this unit vector, so it represents the vector form. And similar way, any quantity is acting y direction and it has a direction, then if you multiply with the unit vector, then that is a representation of the vector. I will show the representation. For example, I am giving here. The example is a distance. A object is moving in x direction. Or east direction. A object is moving east direction 2 kilometers. A object is moving east direction how many kilometers? 2 kilometers. How you will represent this object displacement with vector form? For example, distance, here it is a distance. So distance I am showing with S bar. Vector form is what? S bar. Distance vector form is what? S bar. When S bar is equal to, how much is the magnitude here? The displacement magnitude is 2, because every time vector represent, how you represent the vector? Vector is equal to magnitude into unit vector. So the thing is, the magnitude of the displacement is how many kilometers here? 2, and it is moving which direction? East direction. Let us take west and east. Let me take as x-axis. Then the object is moving in positive x direction. But in x direction, the unit vector is already we discussed as I cap. So you can keep here I cap. So finally, the displacement vector S is equal to 2 into I. So here 2 is representing the magnitude of the vector and I represent the direction. This is how the unit vectors will useful for expressing the vectors. I will give one more example here. The one more example is a force This is example 1. One more example is 2. A force 2 newtons acting upward. A force 2 newton is acting in which direction? Upward. How we will represent this as a vector form? Look at here. Look at here. Now here, what is the name of the vector here? Name of the vector is force. So I represent with F bar. F bar is equal to this F bar. How much is the magnitude? How much is the magnitude? Because vector is F bar, force vector. And how do you represent the force vector? Magnitude into unit vector. Here, magnitude of the force is 2 Newton, isn't it? And the next, in which direction it is acting? Upward direction. Now you can take down and up as a y-axis. When you talk about down and up as a y-axis, so here it is acting in y direction, positive y direction. It is upward direction. In the positive y direction, the unit vector is j cap. So it become what? J. So finally, this is a vector form of force. So in this vector form of force, this 2 is representing the magnitude, 2 represent the magnitude, and this j cap represent the direction of the force. So this is how the unit vectors will help you to express the vectors. Now let us talk about another type of vector. The other type of vector is null vector. The other type of vector is null vector. Null vector. So simple definition this null vector having. The simple definition is, look at here. Any let me write the definition here. Any vector magnitude, any vector magnitude is 0. Any vector magnitude is 0 is called null vector. Simple definition. Any vector magnitude is how much? 0. If this is 0, then that is called null vector. So now, when this is a null vector, magnitude is how much here? Magnitude is 0. But what about its direction? Direction of this vector is undetermined. Direction of vector is undetermined. Direction of the vector is what? Undetermined. So this is about your vectors. I hope you have understood today's topic. So next we'll explain remaining topic. For today, I'll stop the session. Bye.